All right, so this workshop is really just it's gonna be very superficial, kind of like very basic concepts of Python, and just kind of talking about like um, what variables are, what functions are, and things like that. So if you already know all of that stuff, then it might be a little boring, but it's worth it if you're really new to programming, like you said, and you want to kind of like touch up on some of the concepts. So it'll be basically that, just kind of like an intro book and like what are variables, what are loops, what are objects, and that's it.
I I think I have an idea what variables are, what if for loops, while loops are, functions.
Okay.
Objects, not really.
Yeah, no
I don't know if we
worries.
can cover that. I don't know.
Okay, well let's go ahead. Let me start this event. I guess I started on Discord. All right, there we go. So, let me go ahead and get started. The very first thing I normally do when I do a workshop like this is I kind of teach how to install Python, install the IDE, and all that. So, the very first thing you want to do if you haven't done this already, do you have an IDE installed, like Visual Studio Code, kind of like what I have open
Yeah,
right now? Yeah. Okay. Cool.
I have PyCharm.
Yeah, that'll work.
No.
That actually would work just fine. So just for if anybody decides to watch this later on and are kind of watching from a YouTube video, the way you would install Visual Studio Code is really you just go to, you can just Google Visual Studio Code .ide. So let me bring that up here. So code.visualstudio.com is where you would go to download this. It's really good. You can really use any IDE you want. Like PyCharm is fine. It's actually more than fine because it's like has a bunch of packages you can use. This one doesn't. It's really just a text editor, and you can add the packages that you need as you go along. So this is where you download it. Just go ahead and download it. Do the default settings. That should be fine. And then once you install it, you want to make sure actually it shows up in this picture right here, this Python extension. So actually I can bring that up right here. So Jonathan, if you don't have it installed yet, this might be a good part that you can do. So if you go to this little like building blocks or Tetris looking symbol here on the left side, you're gonna search for
Sorry.
Python.
Eric, sorry to interrupt. You're not sharing your screen. Am I supposed to be seeing your screen?
Oh, you don't see it? Here, sorry, one sec. It might be because I'm not focused on it. Can you see it now?
Does anybody else see it? Or am I the only one?
Actually, I see what's going on. Hold on. See change. Can you see it? Yeah?
Yeah.
Okay, perfect. All right, um, so again, this is the IDE, Visual Studio IDE. Um, Jonathan, I was just explaining that if you go to the left-hand side, there's like this little Tetris symbol. If you click on it, it lets you install these different packages. I searched Python. So if you search Python, the very first option is what you want. Click on it and hit install. Mine already says uninstall because I've already installed it. Basically what it does, it just gives you support for Python, like autocomplete and stuff like that. So we're going to go ahead and move on from there. So the second thing you want to do is you want to install Python itself. So if you don't have Python installed yet, you're going to want to go to python.org, and there's going to be like a download tab, and you install it from there. There's going to be something very important you want to do when you download it though, because once it's downloaded and you start setting it up, something like this will show up. Like the very first screen will say install Python version number. At the very bottom, I highlighted it. It says add Python 3.10 to path. If you don't do that, Python might not work for you. So make sure that's checked off, and then hit install now. So that's really important. All right, so we're gonna go ahead and move on. Jonathan, do you already have something that works for you? Some Python setup that works for you?
Sure. I'm not familiar with it, but I remember installing it a while back.
Yeah. Okay, so like let me quickly see if something like a a test source file works for you. So you have Visual Studio open right now, right?
Negative. I have Visual Studio, but I just thought I'd use PyCharm.
Oh, okay, all right,
But
sure.
if you want me to use Visual
Oh
Studio, I
no,
can
never
pull it
mind.
up.
Like PyCharm works just fine. I was just gonna see if like if you needed to troubleshoot
Okay.
anything to see if this works or not. But cool. So I'm gonna go ahead and start a new file. However you do that in PyCharm, that's totally cool. I'm gonna create a new on the Visual Studio IDE. I'm gonna go ahead and open a new folder. I don't have one yet, so I'm gonna create one, a workspace. So yes, I trust the authors of these files. Um, let's see, I'm gonna make a new folder here. I'm gonna call it, I don't know, workshop. Create a new file, test.py. Okay, so we're going to go ahead and start with variables. So with Python, with any programming language, anybody's going to start with the variables as the very first thing you learn. So in Python, they're very easy. So I don't know if anybody has any experience with like C++ or JavaScript or anything else or Java, where you kind of do like int x equals 3 semicolon. That's how you kind of declare a variable. Which means that, oh, I'm going to have an integer variable called x, and it's going to contain the number 3, right? That's how, in any other programming language like C++ or Java, that's how you kind of declare a variable. Well, with Python, you don't need to do variable types. You just do x equals 3, and no semicolon, and that's it. You've declared a variable. It's kind of implicit, so once you assign an integer to a variable, Python just knows like, oh, that's an integer, cool. um, to print. So in order to print something, it's not going to be like C++ where you do C out and then like X and del like that. That's too much. Python is a lot simpler. You can just do print parentheses X, and then we can go ahead and run this. So I'm going to go ahead and debug this, hit run, and mine at the very bottom right here, you can barely see it. Let me see if I can make it bigger. So there you go. The 3 right here, that's the result, right? So we can even do math. You can assign a variable like an arithmetic problem. So you can do like 3 plus 3 plus 3. I'm going to run this again. It should be 6. So I got 6 at the bottom here. You can also, instead of doing this, you can actually do it directly into the print function here. So you can do 2 plus 1. If I were to run this, it'll give me 3. So I got 3 here. Or if I do like, I don't know, 2 times 3. Multiplication, by the way, is by this asterisk. So 2 times 3. That should give me 6. So I got 6. So that's how variables and printing works in Python. Also, it does do what's it called? Order of operations. So if you do 2 times 3 plus 2, essentially it's going to multiply these two first and then add the 2. I can actually do this backwards. So if you're familiar with PEMDAS, like please excuse my dear Aunt Sally, it's going to do that. You know, it should multiply 2 times 3 first and then add 2. So it should be 6, 8. I'm going to run this. So I got 8. Instead of, you would think it'd be 4 times 3, it'd be 12. It's not. It's going to go order of operations. Um, so okay, you can also do kind of something weird like this. You can do, this is true about just about any programming language. You can do something like, let's say a equals a plus 3. It's a little weird because right now it's showing me that it's not going to work. And that's because I need to assign a to something first. So a equals 2. So if you see, let's see, print. Let me test this works out first because maybe it's not going to work. Hold on. Unexpected indent. I indented somewhere. Let's make sure that I'm understanding this correctly here. Or did I indent? So in Python, indents are basically kind of how you declare, like, if I did this, I guess I might as well explain this now before I keep going. In Python, instead of, like in C++, if you did kind of like integer, function, and then you did like x, and then you did this, right? If you did this, it means that everything inside of the semicolons belongs to this block of code. This whole block of code belongs to this because you added these semicolons. Like everything inside of these belong to this, right? And Python, it actually works by indenting. So if I did like integer x 3 equals 3, and I did something like this, like a equals 2, then it means that this entire thing belongs to this. This whole thing is a code block. It's wrong though, because this is not how you make a code block technically. You kind of need to make a function to do that. But that's kind of the error that was happening earlier. I don't know exactly why it was happening because it should technically work. Equals a plus 2. Well, now it's working, I think. So let's try it again. A. Yeah, there we go. Okay, this time it worked. So what I did here was I assigned a equals 3. And then I did a again. A equals a plus 2. So what it does is the second declaration, I'm basically saying take the previous value of a, which is 3, and then add 2 to it, and then give the value to a, like a will now equal 5, right? So I guess this is a really good way to kind of explain that you got to be careful about where you assign variables, because if you use the same name later on in your code, it might get reassigned, and you want to be careful about that. A few important rules about Python and declaring variables is that you can't start with any number. So like if I were to give a variable a name, I can do something like my name, so Eric equals 2, but I can't do something like 1 Eric equals 2. That's going to cause you an error. And you can tell right here that's kind of giving me an error in red, like that's not allowed. If I were to run this, it tells me, hey, that's illegal. So can't do that. You also can't do any symbols like this, like exclamation mark equals to. So any of these symbols here, hashtag money symbol, this symbol, and this symbol, this symbol, this symbol, this symbol, and this symbol. None of those. You can't do any of those before your variable. Individually, together, it doesn't matter. Can't do those. All right, so you got to be careful about how you declare your variables. And the last thing about variables that we can talk about is that Python implicitly converts numbers to floats. So if you don't know, if you're new to programming, a float is something like 4.21. So it's a decimal, essentially, right? So if I did Eric equals 4.21, this variable is now a floating type variable, right? If I just had the 4 without the period, it's an integer type variable. So I'm going to put the 0.21 back, because if I did this, if I did times 3, you would notice that this is a floating type and this is an integer. So there's two different types trying to do math together. What's going to happen, Python is going to implicitly convert the result to a floating type. So anytime you multiply or add a number with a floating type variable, it's going to convert the whole thing into a floating type. So if I were to print this, print Eric, it should give me 6.21 or something like it. So it's actually going to be so it should be 12 point something, whatever. But it's going to give me a long number. And if you were to run this on a calculator, it should be more of an exact number. So I actually have a calculator right in front of me at, let's see, 4.21 times 3. The number is actually 12.63. But if you notice at the very bottom, it's giving me a number like 12.6.299999999. It's just a programming thing. Anytime if you were to do this in C++ or Java, it's going to give you a very similar answer. This is just kind of like a floating type error that languages do. So you got to be careful when you do math in floating type. It's never going to be accurate with floating types. So anytime you can, when you do not need a floating type number, it's more accurate to use integers than floating types. So
I have a question.
yeah, go for it.
How big can the number be?
That's gonna have to be a Google question. Let me look for it. I can Google that for you. So let's see, floating type. Like, you mean for floating type or for integers? Exactly. Floating type Python.
Like, how big can you make a variable, and what happens if you go over that limit?
So it says Python floating type values are let's see, the maximum value you can give a floating type number is approximately 1.8 times 10 to the power of 308. So there is a max number. If you go past that, you're gonna gosh, it's been a while since I took a class on this, but basically it's going to be kind of like what a memory leak. I don't know if somebody can correct me on this, but if you go too far past the limit, it will it's not going to work. You're gonna it's gonna be, I think, stacked overflow. I think is what happens.
Yeah,
So
that sounds about right.
yeah, so if you do stacked overflow, essentially your program's like, this isn't a real number, and I don't know what to do, and your computer just kind of either keeps running forever or it just stops running. Your computer knows what to do in that situation, like the Python interpreter knows what to do in that situation. If you go past the limit, usually in most use cases, you shouldn't go anywhere near the limit. So there's creative ways to get around it, which if you ever take like an assembly class, you'll kind of understand why that happens, um, and how creative you can get to kind of work around the issue. And it's kind of out of the scope of this workshop to kind of describe what you can do, but it's kind of how, if you ever decide to become a software engineer and you want to make like an Excel sheet type software, you have to find ways to address those issues so that your program doesn't like go over the limit of the variable and stuff like that. Um,
Good
so
to know. Is it a hardware limit or a software limit? Is it because
hardware,
of Python or is it because of the hardware?
hardware,
Okay,
yeah,
gotcha.
it's a hardware
Yeah.
limit. It's why you have 32-bit processors versus 64-bit processors. A 64-bit processor can hold more data versus a 32-bit processor. Um, but that's all like very low level, and Python kind of takes that information, like it knows that it's in a 64-bit processor, so it'll interpret your program to work with 64-bit, so the limit is kind of increased. Whereas if you were to run your program on a 32-bit processor, you might have a smaller limit to how much data you can store in a variable. Um, and on and on. You can
Good
probably
to
store
know.
more in a 120 whatever as the higher, but I think 64 is the more common. Okay, so strings and string manipulation. So again, if you're new to programming and you don't know what a string is, really is all a string is a sentence, right? So like, um, the brown dog jumped over the big brown log. Um, that whole thing is a string. It's just a sentence. In fact, it doesn't have to be a sentence. It could be a whole paragraph. I could go on and on and on. The owner of the dog lives in the house. I can keep going. This whole thing is a string. It's called a string because these individual letters, individual characters, even the space here, even the space right here, they're characters. The space is a character. The letter is a character. Each one of those are called a character. Um, so it's called a string because you're stringing all of these characters together, right? But when I put them all together, it's a string, and I can assign it to a variable. So I can say this string equals this entire thing. And if I were to print this string, and I were to run this, it's going to print that entire thing. So I just printed a whole string, right? So that's really cool because you can make programs that handle text. That's how you kind of do that kind of thing. You can also do single. So right now, you see how I did like double quotation marks? That's how you surround the you surround this anytime you surround a sentence or letters or whatever or characters with a double quotation, you're saying that you're using a string. So actually, I'm going to delete this whole thing. It's too big. But if I did single quotes, it's this also works. Single quotes, uh, single quotes work, and double quotes work. So if I were to run this, it'll be the same thing at the bottom. Um, One of the most important things about strings in Python is indexing. Indexing just means that so this whole string is essentially a an array. If you don't know what an array is, it's exactly what I just said. So a string is a string of characters. An array is essentially a string of data, right? So this is next to the letter T is next to the letter H. The letter H is next to the letter I, next to the letter S, and on and on and on, right? So imagine this was a neighborhood. Each character is a house. So there's a house called T, a house called H, a house called I, and you're a mailman. You want to deliver the mail. You need the address to the house called T. To do that, you need to say, so let's say over here, right? This is the mailman. Print is the mailman. Uh, the address will be this string, uh, square bracket, 0, right? So the address to the letter T is 0. Okay, I'm going to run this, and I only got the letter T at the bottom as my output. Okay, so right now you're the mailman and you delivered your mail to the right address, 0. So you can assume that the next address will be 1, right? So the letter H is 1. So if I were to output, why can't I delete this? Oh, I know why. Huh. Okay, there you go, 1. So if I were to run this, now I got the H, and on, right? So if I did 2, I get I, and on and on and on. So that's how you index. And indexing just means you're basically looking for the right letter in the string, assuming you know the index value. Um, Another thing you can do, Python supports negative indexing. So if I did, for example, -1, what do you think will happen? Um, Essentially, -1 is going to give you the very last item in the array, the string. Okay, so I'm going to get the period. I'm going to run this. I get the period. So -1 gives me the period. So we can do something called slicing. So I'm going to delete everything inside of the square brackets, and I'll do instead something like I'll do 2 colon, and basically what it'll do, it'll print everything from index 0, 1, 2, everything after the letter I. So I'm going to run this. Actually, everything including the letter I. So this also works. So it doesn't print out the first 2 letters. I can do, let's say, I don't know, I'll do from index 1. So you get the idea. You can do between a range. So if I did from 1 to 4, it'll print everything from this one. So 1, 2, 3, 4. So only this will get printed out. I'm going to run this. So there you go. That's how that works. So there's some basic methods. So if you don't know what a method is just kind of like a function. Well, it is a function. So let's say I did, let me create a string again. My string equals the dog is brown. Okay. I'm going to print this, print my string. I'm going to run this. So now I get the dog is brown. Okay. So I'm going to create a new variable called cap string. I'm going to do it so that everything in my string gets capitalized. So say cap string equals my string dot upper. If I did that, so what's going to happen, you can probably assume what's going to happen. Everything in my string is going to get capitalized, but it's not going to save it into my string. It's going to save it into my new variable called cap string. So if I were to print my string, nothing's going to happen. It's still going to be the same exact string. But if I were to put in cap string, it's going to basically change everything to capital letters. So the dog is brown, it's yelling at me, so it's in capital letters. So we can also do capitalize. If I did that, it's only gonna capitalize the first letter. So if I were to do this, make the first one lowercase, so you can see the difference. So if I were to run my string, whoop, what did I do wrong? What does it want? String object has no attribute, capitalize. Oops, I misspelled it. How about now? Try this again. Capitalize. There we go. Okay. So the string got outputted, everything's lowercase, and if I were to output cap underscore string, it should give me the same string with the first one being a capital letter. So that's how that works. There is also another method called split. So if I did my string dot split. I'm still going to call I know it's no longer going to be capitalizing anything, but I'm just going to keep this variable the way it is. So now if I do this and I did split after the letter D, so basically what it's going to do is it's going to split the two strings. So everything from here on outward, it's going to get split. So if I were to output this, it created essentially two strings, one called the, and everything after the letter D. So it's og is brown, right? The only thing that you need to note here is that the D is kind of like the pivot. It's not going to include it. So once you output this, that's going to be missing. So there you go. That's the split method. Um, One really cool one is called print formatting. So if I were to, let me delete this, and I did something like, oh, I'll do something like, um, the dog is, I'll do this. So let me set it up first here. So I want to get this right. Format, um, I don't know, blue. So what I am doing here is I have a string that says the dog is blank. And the way so I do this by two curly braces. You're kind of saying I'm going to insert a blank. I'm going to insert this blank with another word. So I'm going to do dot format, and then in the format I'm going to put in the word that's going to replace this semicolon. So it's going to be blue. So let's see if this works. My string. So it should say the dog is blue. Yep, so it worked. The dog is blue. So this is called print formatting. You can also do it with more than one. So you can say the dog is blank and also blank. Maybe I want to say, I don't know, the dog is annoying or something. So if I were to run this, it'll say the dog is blue and also annoying. So this is kind of useful if you want to do like some automation or some more dynamic programming where you don't want to just to say a string. You want to get like user input, and the user has to say, oh, my dog's color is brown and they're cool, right? You want to get some user input. This is how you kind of do that.
Question
Yeah. Sorry, do you have a question?
is sorry. Yeah, please. I'm not sure if questions are allowed. Should I not
No, yeah, go
ask
for it.
questions?
No, it's fine. Totally fine.
Okay, great. Because I don't want you to continue and then we lose the context. So can't we just use variables like in the string? Why use format
You mean something
method?
like this?
Mm,
Um,
I mean, can't you? Isn't there a way to add variables to a string, or is that how you do it? You have to use format, the format method.
this is it actually. So this is actually this is actually the next thing I was going to show. So like, yes, you can, but this is how you would do it. So if I did like x equals blue, sorry, x equals blue, and then I did b equals annoying, right? I have to define the variables ahead of time somewhere. And then inside of the semicolons, you put in the name of the variable. And then in the format, instead of giving it the name of the string, I just do the variable. It'll be the same thing. That's how you would do variables inside of the string. So if I were to run this, oh, that didn't work. Sorry. Hold on. I might have to define it
'Cause
here.
I think in JavaScript you can just like concatenate, right? So this is different with Python.
You can concatenate here as well. Um, I can try to test it in a
Okay.
second, but let me make sure that this works first because this is supposed to work. There we go. So I guess the only way this will work is if you actually define it here inside of the format. So you can do variables inside of the string, but you have to kind of define them inside of the format the parentheses. To concatenate, this is one way to do it. You can do also, I don't know if you can actually. So I'm not 100%, but let's try it. So x equals, let's see, car plus blue. So ideally, this should kind of like add together, right? Oops. And make one string. I don't know if it'll work. It did work. There you go. So you can concatenate, and I'm assuming that it'll be just as easy to say A equals car, and then I did B equals blue, and if I added them together that way, like if I did A plus B, then that might work too. Yep. So you can do that too. Like that works fine. So
Can you also add the actual variable, like in the string itself? Is there a way to do that, or do you actually have to use the plus? Like,
add
so
the
you would, yeah, how to explain it? So maybe a equals quotation marks hello quotation marks, and then hello is a variable that says hello world. Would that work or no?
um
Is there a way to do that?
so you mean kind of like, I don't know, do you mean like this? And
So
then
like a equals
A
hello.
A
I
equals
mean a
hello.
equals quotation mark hello quotation mark,
Okay.
and then hello is defined somewhere else as hello world.
So you mean like this? Like that?
Yes, and then yeah, and then but world is defined somewhere else, right?
Oh yeah, so like exactly like we so like it'd be the same thing
Like that,
essentially.
right?
Yeah. Yeah,
Right.
that's
Is there a way?
so that'll, yeah, that'll work. So
Okay,
any,
okay,
it's really any
gotcha.
strings. You basically can concatenate any strings. It doesn't matter what strings you use. So those two would work. You can do anything really. You can, I can add a third one. I can keep adding more, like keep adding more to this like equation, right? And then it'll be the same thing essentially. So okay. So next thing is lists. So I talked about an array earlier. There's in programming, there's different ways of doing collections. So a collection of data is just kind of like a string would be. So x equals the dog is brown. This is a collection of data because it's a bunch of characters together in one thing called a string, right? We can also do something called a list. So if I did my list equals square bracket and I did 1, 2, 3, this is a collection of data of a collection of integers 1, 2, 3. So this list is a list of integers. So this is pretty cool um, because, like I said earlier, using the mailman analogy, if I wanted to print the first element of this list, like just the one, it'll be 0. Anytime in programming you want to like print out like data like this, that's in a list or that's in like an array, it's gonna go from 0, 1, 2, 3, 4, on and on and on. It always starts with 0. Uh, so actually, the way you print this out, I don't know that actually you print it out with like this, but we can try. I think this is, oh, it's because I didn't spell it the whole way through. There you go. So this should just print out 1. So there you go. It printed 1. But if I want to print number 2, I say I want to print out index 1. So now it printed 2. So there you go. So in a list, you don't have to just have one data type. So right now I just have integers in here. You can have like 1, 2, 3, and then you can do like the dog is brown. So the dog is brown is an entire string, but that is, so this is, so if you were to tell somebody, hey, how many elements do I have in this list? There are 4. 1, 2, 3. This whole thing is 4 because a string is one thing, right? And then I can add a fifth one. I can do true. I can do I can even add like another list within a list. I can do another like 1, 2, 3. So you can get really, 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 really dumb really quick. Um, so if I wanted to print the string itself, I just need to do like, I need to do so it's gonna be 0, 1, 2, 3. It's gonna be 3 to print the string. Run this, so the whole string got printed. Okay, and then if I wanted to print, so this is what's called a Boolean value. A Boolean value is just going to be true or false, right? So this is a data type on its own. So if I want to print number 4, there we go, printed true. And then this one's confusing because you would think that to print this, you just need to say 5. And that actually might work. You might just print this whole thing out. And actually that might do that. So let me run this, printed the whole thing out. So this whole thing got printed out 1, 2, 3 by saying I want to print out index 5 because it's the fifth element. But if I just wanted to print one thing inside of this list inside of a bigger list, I have to say 5, and then I have to do something like uh, 0, like that, and it'll print like the first one. So element 5 and then element 1, element 0, index 0, right? That's how that works. And the same thing, like I said earlier, if you do -1, if I did -1 in here, it'll print the last element in the list. So if I were to run this, last element. So there you go.
I
What's the
have a
difference
quick.
between an array and a list? Sorry, go ahead.
Okay, go ahead.
Uh,
Okay, what's the difference between an array and a list?
the difference between an array and a list. So it's kind of a data structures question. In an array, I'd have to pull in my textbook honestly, but I think the difference is that in an array, I guess by definition is just something that if you were to look at a like a memory stick, like RAM, right? There's memory addresses. I'm gonna make something up and say like in a computer, memory address looks like something like this. I don't know, something like that, right? Like in your computer, if you were to say I'm gonna print out like this exact address in your memory, and let's say the value equals 3. Like if you were to tell the computer, hey, I want to print out this memory location, what does it say? Oh, it says 3, right? An array would essentially be anything that like this would be 3, this would be 4, this would be 5. So an array is just like literally just anything where data is sequential in like physically in the data. So the memory location, so like remember the house analogy where I said like memory location 0 and then memory location 1, 2, 3. Everything is next to each other physically in your memory. That's an array. All the data is like literally one after another. um, that would be an array. A list um, is kind of similar. The difference with a list, if I could remember correctly, it's just kind of set up differently. It has different functions, different methods. um, a lot of these data structures kind of seem similar and are kind of used the same way, but um, an array and a list could probably be the difference could be as small as like maybe a list just has like a function where you can insert something somewhere, or an array doesn't. I can't tell you exactly because I forgot honestly, but it's a data structure question. It's really just kind of like the
Okay,
way it's programmed. A list is programmed differently than an array is.
okay, yeah, no worries, thanks. And do you know why you should use one over the other? When is it better to use one over the other?
Um, I can't tell you with the list or an array. Let me use a better example that I can probably explain better than a list or an array because I forget the differences between the two. Let's say a vector and an array, right? An array is something where the data is physically next to each other in your RAM. Okay. Um, a vector. This is going to be a C++ answer because I can tell you this in C++. I don't think Python has vectors actually, but what a vector is in C++. I don't know if you have experience with C++. A vector, you do something like vector int x equals, and then I forget if it's like semicolon or something like that. 1, 2, 3. Then you do this. So this whole thing, so x is a vector that contains 1, 2, 3, and then an array would be something like I think it's something like this, like integer 10 uh, y equals 1, 2, 3. Actually, we're gonna do 3. So the differences between an array, the array would be this one, and a vector would be this one. An array is static in the sense that it's you predefine how much data will be inside of the array because it's physically you have to physically tell the RAM, hey, I want to reserve this many spaces of data, and in this case I said 3. I want to reserve uh, 3 bytes worth of data. Byte would be like I forget how many bytes or how much data that would be, But basically, when you say 3 bytes, it would be enough to store 3 integers, right? That would be an array. 1, 2, 3. You can physically, all this data is stored together. A vector is different in that you don't have to predefine how much data you want to store in a vector, because this data isn't stored next to each other. This is one memory location. Like if I were to say like where this data is located, I could say like x, 1, 2, whatever, and then that would be equal to 1, right? This is that memory address. And then for number 2, it wouldn't you in an array, because they're next to each other, the address would be something like 2, right? It would be right after the one previous to it. But because this is a vector, it's not going to be the same. It could be literally anywhere else. So that's a 2. 0x blah, 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 blah. That's another memory location that's equal to 3. So vector, it's literally like just grabbing random places in your memory and storing data and tying them together. Whereas an array, everything is together. That's why you have to predefine how much data is here, versus you don't have to do that here. But that also means that this is slower versus this, because actually I think it's the other way around. I forget. Anyway, that's kind of the small differences between the two.
I didn't know that. Helpful. So a vector is similar to a list, basically, in Python.
Uh,
I'm not familiar with
a
C++.
vector. Yeah, I would say so. I guess so. Yeah, I guess if you were very superficially, a vector is similar to a list. There are going to be a lot of differences. Once you get to data structures, you'll kind of learn about all those differences. They're not exactly the same because they function differently, and every single programming language interprets what those differences are. So like a list in C++ is kind of a different thing than a list in Python. They are probably very similar, but they were adapted differently, essentially. But in the context
Okay.
in the context of Python, this is what a list is. And obviously, like I don't need to tell it, hey, I want like I want 5 objects in this list. I don't have to say this. It's dynamic. You can keep adding and adding and adding more and more and more.
Awesome.
So
I'm sorry, last question. So what happens when you actually like add to an array or drop from an array? Does it actually clear the memory that's adjacent to the other memory addresses? So it follows that order that you specified. That there's like an order or reserved
you're saying like if I
space
were to
for
make an
an
array.
array.
So I don't. So Python doesn't have arrays. I don't think it has arrays because Python is kind of a dynamic language.
Okay, okay,
So
gotcha.
you don't have to worry about arrays in Python so much. I just call it arrays because it's easy to kind of explain what a string is. A string, by kind of definition, is an array, right? It's easy to explain that this is kind of like what an array is. But Python doesn't have arrays, really. It has things like it, but you won't have to worry about it. So you don't have to worry about that problem with Python. In C++, you might have to worry about that question, but not in Python.
Okay, thank you.
Yeah, so what if I want to add, so like I already created a list here, right? What if I want to add something to it? Okay, if I want to add a new element after I've already created it and I printed something, so the way you do that is you do mylist.append, and then I could add something like false. Okay, so that is going to add at the very end of the list. So if I were to now print my list, you'll see that my new element shows up. Okay, at the very end. You can also do extend. So it's the exact same thing as append, except the difference is you add multiple things. So mylist.extend, and I did false, 1, and then I did another string. Okay, so there's 3 elements here, and if I were to print my list, it should add all of those elements at the end. Oops, what did I do wrong? takes exactly one element. Oh, it's because I need to make this a list. So let's do this again. There we go. So if you want to use extend, you want to insert a list. So you have to format it as a list with the open square brackets. That's how you would do that. To remove something from a list, you do this. So I'm going to delete this. So right now our list only contains these things. But let's say I wanted to remove something. So I did my list.pop. Okay. Actually, I'm going to do something like item to show you how this works. Because when I remove something from my list, it's going to remove it, but it's also going to store that removed element into my new variable. That's why I did this. Item equals my list.pop. So now if I were to do print item, it'll show you what item I removed. So it removed the very last item right here. This whole thing is what it removed. So that's how that works. You can also reverse a list. So let's do this. This is actually really useful. So 1, 2, 3, 4, 5, 6, 7, 8, right? I have a whole list of numbers. Let's say I want to reverse that list. So I did something like my list dot reverse, and I printed that list. Oops. Let's do this. That should work. There we go. Okay. So you have to do it on the list itself. So my list dot reverse, and it reverses the whole list. So that's pretty cool. You can also sort it. So like if I had everything out of order and I did like 4, 3, 1, that blah 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 like that, and so that's not sorted, so I want to sort it, I can do that, run it, and it sorts it automatically. So that's how you can do that. You can also do matrices or matrices. I don't know if anybody's taken calculus and learned how to do matrices and all that, matrix math, but this is really cool if you want to learn to do stuff like that. So if I wanted to make a matrix in Python, I can do something like matrix equals, I can do something like, 1, 2, 3, comma, so that'd be the first row. I can do another one. I can do 3, 4, 5. That'd be the second row, and then the last row would be 6, 7, 8. Okay, that's a matrix. And because I already taught you how to do nested lists, so if I wanted to print like this number specifically, I would have to do so it'd be, this whole thing is element 0, this is element 1, so I'd have to do 1 and then add a new square bracket for the second index, and I would do 0, 1, so it'd also be 1, and that should print out 4. Sorry, this is called matrix. Run this, and I get 4. So that's how you do matrices. So there you go. You can also do a kind of a complicated. Okay, I'll show you. So there's something called list comprehension. If I were to do something like first column equals row 0. Actually, I don't know if this will work. We'll see. For row in matrix. Let's try that. And now we're to print first column. Run this. So cool. I printed the first row. Okay, so here's what I did. What I did was I created a variable called first col, right? First column is what this stands for. I assigned it this kind of like this weird list open square bracket kind of thing. This is a loop. I created a loop inside of it. What I did was I said, hey, I'm going to create a variable called row, okay? Just within the context of this function, I'm gonna create a variable called row. I want you to print, I want you to get the first element inside of the matrix, the first element 0 inside of matrix, okay? And I want you to print it out, okay? I want you to print out the first element in matrix. And that's it. So that's what I did. If I did row 1 for row in matrix, it's going to give me the second one. And on and on. So that's another way to do it. All right, so dictionaries. So does anybody have any questions so far? I don't know if there was a question. I thought I saw.
Called? What's that called? Where you put the loop inside? I've never seen
The
it.
loop inside.
Yeah, the
Um,
first column equals, and then you put the loop inside that matrix or the what is that called?
in this case, this was, I think they called it a list comprehension, but it's really a for loop. This is just a for
Oh,
loop.
okay. Inside
Yeah.
um,
So this is just a for.
the brackets.
It's like a very like shorthand for loop, and I'm actually going to go into more detail of how this works in a few minutes. So this is something called a loop. A loop is just something that goes over something over and over and over again and prints data over and over and over again until it stops, essentially.
No,
So
yeah. No, I know what a loop is, but why did you put it in the brackets? I never seen that before. In the
because
bracket.
this is a list. We're basically creating a list, and this loop is outputting a list. So essentially, this is just kind of outputting everything in here as a list. Kind
Cool.
of. So
Okay.
like so if I change this back to 0, we're basically saying, okay, hey Python, just look at the first element. So that's that's 0, index 0. Look at this first one, and then output every single element in this list, essentially. Does that make sense? We're
Yeah,
just
it's yeah.
So we're looping, but we're just looping through this. So we're saying, okay, loop through this, loop once, loop twice, loop 3 times, and output it as a list. This whole thing will be a list.
Okay, thank you.
That might be a little confusing, but it might make more sense when I get to the loops. Hopefully fast enough, because I don't want to go too long. Okay, so the dictionaries. So dictionaries is another kind of data collection type in Python that's kind of like lists. So let's say I have a dictionary called my stuff, and I wanted to store something. So this is going to be kind of cool because this is going to be a key value relationship. So this is how it works. Key 1, colon, value, value 1, and then comma, and then I did key 2, and then I did colon, and then I did value 2, and then I did, and you get the idea, right? So key 3, colon, value 3. Okay, that's the dictionary, and it works the exact same way as a list, only that you can obviously tell where the benefit, what the benefit is in a dictionary is that instead of using index values of like 0, 1, 2, you can use the name you gave it. So you can call it by the key. So I can say key 1, key 2, key 3, and then it'll give you the value depending on you calling it. So let's say I did print my stuff, and I said, oh, print out key 1, and it should give me value 1. So there you go, right? That's a dictionary. So it's pretty cool because you can give the indexes names, basically. So dictionaries are mutable. Essentially, that just means that we can change the values by reassigning the keys. So let's do something like, I don't know. Let's do something like, so we had my stuff, and I can say my stuff equals key 1, and I could assign it something else. I can say value 24, and I were to print this again, and I were to say print my stuff key 1 that should print out value 24. So it now no longer will print out value 1, it'll print out value 24. And so there we go. That's how you do that. So we can also add a new. So let's say like you wanted to add a new element like at the very end here. So instead of append, I actually have no idea if append would work. I can try that. I don't know if it will. Let's actually try it. I don't know. My stuff dot append. So remember, a list has append, and I wanted to say key 3. Actually, I can immediately tell you that this will not work because you need two. You need a key and a value, and append does not support that. So if I were to try this, value 3, yeah, it's not going to work. So remember when I said the differences between a list and an array and a vector, that they all seem kind of similar, but they're adapted differently because they have like different functions and stuff. This is like one of the big giveaways, is that a dictionary does not support append, but a list does, right? So if you wanted to add a new element at the end, you have to do it a different way. So a way that makes sense for a dictionary would be to say, oh, let's add key 4 and assign it value 4, and then okay, and I wanted to print this to make sure that it worked. My stuff, and I wanted to say it's 0, 1, 2. That should be index 3. So now that should work. It should have worked. What happened? Let's see, 0, 1, 2. Oh, it's because it's not an index. It's going to be key 4. Let's try that. There we go. So that worked. All right. So now we're going to do a few more data collections. We're going to do tuples, sets, and booleans. So tuples, sets, and booleans. First of all, a boolean, I think I already went over what these are. So true, false. These are booleans, okay? It's only just two, just true or false. There's nothing in the middle. It's either or, okay? True or false. So if I were to assign x equals true, that's going to be true. Y equals false, that's going to be false. If I'm going to print this, it's going to be true, right? You cannot add these together, so you can't say x plus y because that doesn't make sense. Actually, who knows? We'll see. Actually, it doesn't make sense. And that's because technically you're adding 1 plus 0. So it's actually 1 plus 0. Oops, 1 plus 0. So those actually kind of work the same way. 1 is true, 0 is false. So that's why that works. So then that's what booleans are. So now we're going to go over tuples. Tuples are another kind of data collection. Oh, by the way, if you wanted to make comments inside of your source code, like if you were to write an actual Python program and you wanted to add comments within your program, you do this. A hashtag, okay? Hashtag and then whatever. So this is a comment. It means that when you run your source, this isn't going to show up in your output. If I were to run this, there's nothing, absolutely nothing. So that's what that is. I don't know what this is. I'm going to delete that. So there you go. So tuples. So now we're going to go over tuples. Okay. So tuples are kind of like a list, but instead of brackets, we're going to use parentheses. 1, 2, 3. Okay. This is a tuple, not a list. A list would be s equals 1, 2, 3, right? So kind of like a list, to index through these, you're going to say t open square bracket 0. So if I were to run this, it should say 1 because we're saying I want this one. So you can also have different data types within the tuple. So we can say like a, we can say true, comma 1, 2, 3. We'd say 1, 2, 3. So if I were to do this now, now I'll get 1. Okay, if I were to do 1, that'll be true. Okay, and on and on and on. So the difference is that between a tuple and a list, you must be wondering what's the difference. They look the exact same. There's, I mean, why have a different thing called a tuple? It's because a tuple is immutable. A list is mutable. This just means that you can't reassign values, okay? Like you can't change the value of this element like you can an index. So here, let me give you an example. So S, if I were to print out S, do this, S0, that's going to print out 1, right? Run this, 1, cool. But if I wanted to say S0 and I wanted to change the value to, oh, I don't know, 10, and I were to print this out, it should give me 10 because I changed the value. So that means it's mutable. That's what mutable means, that you can reassign values within the list. A tuple, you can't do that. So if I did T0, this should now get reassigned to 10, technically. Ideally, that should work. If I were to run this, it doesn't work. It doesn't like it. You can't do it. So that's the difference between a list and a tuple, is that a list is immutable, a tuple is immutable. So that's how that works. So now we're going to go over sets. Sets are kind of cool. So let's create a set. So let's create an unordered set called set. That's how you create it. So x equals set, parentheses. We're going to add something to it. So x dot add 1, x dot add 2. And then we're going to print this, print x. That'll be our set. 1, 2. Okay. So these are unordered. So let's say that we add another element. So x dot add 4. Print this out. 1, 2, 4. So this is unordered. So technically, I actually don't know if this actually will work, but technically, every time I run this, it should be a different order. So it shouldn't just be 1, 2, 4. It should be a different order next time. One of these times it should. I guess it doesn't want to work this time. You just have to believe me. Let's try to add something. Let's see, x dot add 6. Or maybe I'm full of it. X dot add 11. Let's see, let's run this. Yeah, you just have to believe me there. It's not going to work. Okay, so a great technique to take advantage of this is to duplicate elements from a list. So let's do this. Let me set this up first. Hold on. Converted equals set. Let's do 1, 1, 1, 1, 1, 2, 2, 2, 2, 2. Oh, yeah. Okay, so 2, 3, 3, 3, 3. Okay. So here's the thing about a set. A set only takes in unique elements. Okay? That means that when you create a set and you add duplicates, they're going to get deleted. So if I were to print this, if I were to print converted, it should only be 1, 2, 3. There you go. That's a set. Okay? All right, so control flow. Control flow just means that you're comparing things together and adding logic to it. So I already kind of introduced the concept of true and false. That's really important to know in control flow because it kind of relies on that. So let's say I said 1 equals 1. The way you tell a computer to compare something together, in just about any programming language, if you were to compare one element with another element, you'd do an equals sign. Okay? Because if you just did one equals sign, you're assigning something to something, right? You're saying like x equals 1, that means x now has 1 stored inside of it, right? But if you had a second equal sign, you're saying does x equal 1, okay? Kind of like the conventional meaning behind equals. So to define equality, that's this. So this should equal true, right? You know that by looking at this, that this should equal true. If I did something like 1 is 1, like this, that should be false because these are two different data types. That won't work, okay? Inequality, to test for inequality, you do something like 1 does not equal 1. right? You do that by the exclamation mark and then equal sign. That's how you do inequality. And this should technically be true, right? Because you're basically saying does one and do does one not equal uh, the string one? True. It doesn't equal. So it's true. It's confusing, but that's how it works. Um, Operators. So operators are uh, exactly kind of how this works, except that you're using things like this. Okay. So if I did something like if 2 is greater than 3, okay, print uh, uh, false because it's not true. Okay. Here's the problem. Is this going to run? This is the operator, by the way. This is the operator, which you should know if you've ever taken a math class. So this should not run because this is never going to be true. If is always going to test for a true statement. If 2 is greater than 3 is going to be false, so it's not going to run. Nothing happens. Okay? But if I did it the other way around, is 2 less than 3, I'm actually going to change this to true because it's true, then I'll get a value. I can literally change anything underneath here to do anything. So basically, I just introduced you to what an if statement is. This is really cool because now you can do things like you can set conditions. You can say, okay, if as long as this is true, this gets run. But if none of this is true, then skip this and then just keep going to the next part of the program. Okay? That's kind of the foundational parts of what programming is you're adding logic, right? So let's say 2 is, let's say this is always going to be false, the first one. So if this doesn't run, but you still want something to happen, you create an else statement, right? That means that you have kind of like a safety net so that in case this is false, then something else will run instead. Okay, so print false. False. So if this is false, then print false. There we go. So that's how that works. If, else. I don't know if that makes sense. Does anybody have any questions?
I
Okay.
have some questions.
Yeah, go for it.
How do you do multi-line comments?
Multi-line comments?
Is it just a hash a pound sign for every line?
Yeah, I think it's just a pound sign in Python. In
Okay.
Python, it's just going to be like all this. And then you just keep doing this.
Okay.
This.
And then
This.
for the sets,
Right.
can you does it work for a for strings? And what happens if you have string duplicates?
Um, good question. We can try it out. I have no idea. Let's see.
Okay.
So x equals set, and then if I was to do set dot add this x dot add that. I have no idea. No clue. Okay, so that's a set. But then if I did like x dot add this, so ideally this should only be 2, right? Instead of 3. So let's see if it works. I don't know. Yeah, it does. It does work. Yep.
Okay, that's cool.
Yeah, as long as like it's the exact same. So if I did it like this, that probably won't work.
Okay.
There you go.
And I have a question about these data collections. Is that what they're called? Data collections?
That's
No, right?
that's what I call them. They're data structures essentially.
Data
Collected.
structure. Okay. So, would it be so? How would you store large amounts of data? Like, let's say you have a data. Would you be able to, if you want to create a database, would you use these structures? Like a terabyte of people, like a contact information or just data. Would you
Uh,
use these data structures?
yes. So that's kind of getting into more like a concept called a database. So if you don't know what a database is, maybe someday you want to learn something like SQL. You already kind of see like I already have kind of some of that stuff installed already. I don't want any of that right now though, so how do I get rid of it? Anyway,
So SQL would be better for that, not Python.
well, you can use SQL in Python. You can use Python to run SQL commands. you can use something actually, some people in here might be like, oh God, but Django is actually something that you can use to create an SQL program. Uh, so an SQL is a database kind of framework essentially. Why did this come up? That's what you use to store large amounts of data. It's basically like a giant Excel sheet. I don't know if you know what an Excel, if you ever seen like all those
Yeah.
little squares and everything. SQL is like that, but it's like a programming language almost. It's weird, right? But that's what you would use. It's a giant, massive thing where you store data. You can use Python to run SQL commands to run large amounts of data. And people that created SQL probably underneath the hood use things like lists. They probably use things like lists, dictionaries, and stuff to make SQL work. You just got to know that time complexity is really important, like which ones of those data structures are faster than other ones to make sure that SQL is as fast as it can be. So yeah, lists and dictionaries and tuples and things, people use those to build bigger and cooler apps like SQL. But you just have to know a little bit about, how fast those would run to make your program run as fast as it can. So
Yeah.
yeah. All right, so that was an if statement. So if 1 is greater than 2, we can do something like and 2 is greater than 3, then print hello. Okay, I don't know if that's going to run. I don't think it will. Else print bye. Okay, so is this going to run? Okay, I don't know. Is 1 greater than 2? No, right? That's false. Is 2 greater than 3? No, that's false. So I can already tell you this is not. It's going to run bye. It's not going to run hello. So if I were to run this, I get bye. What if one of these are true though? So if I were to change this to 1 is less than 2, I mean, that's true if it's just looking for a true statement, right? The problem is though that we have one true statement and one false statement, and we have one that says and. When you have and, both of the things have to be true. So this has to be true and this has to be true. So this still won't run. It will still give me the else statement. Okay? What if though, instead of and, I did or? Or, you're not going to type in or. I mean, you can technically. You can do that. That might work actually. So let's actually run this. That should run. That should run hello. And it did work actually. Okay, cool. So basically what this says is that, okay, this is true, but this is false. But as long as this is true, we'll run this. Both of them don't have to be true. Okay? You can also do, I think you can also do this. No, you can't. Okay, Python doesn't support that. In other programming languages, you do this instead of or. But in Python, you use or. So that's and or. Okay? How you would use and or. So again, indentation is important. Make sure that if I were to add more things here, x equals 3, y equals 2, print 3 plus 2, all of this will run only if one of these two are true. If this if statement is true, okay, only this will run if these things are true, because everything is indented underneath this. Okay, all of this belongs to this. Because if you notice, I have an equal amount of spaces underneath it. It means it belongs to this. So that's how tabbing works. Okay. You don't need these parentheses. You can actually just do this. You can actually just do that, I think. So that should work also. That should be fine. Okay. You can also do like, let's say I did and, okay, and here, and then I wanted to do a second one, and a second else, a second if statement. I can do 3 is 3, print the second one is true. Okay, so this is going to be false because 2 is not greater than 3. So none of this is going to run. So because this is false, it's going to go to the next if statement. So the reason this is called elif instead of just if is because if I just did if, it would separate these two out. Essentially, these would be two different if chains, but I want them together, so that if this is false, it moves on to the next one, and then it tests for the next one, and then if this is false, then it goes to else. Okay, so this is going to be true because 3 is equal to 3, so now it's going to print the second one is true. So that's how that works. That's elif. That's how that works. But what about a for loop? I already talked to you guys about a for loop. So actually before I do that, let's create a sequence. 1, 2, 3, 4, 5, 6, 7. Let's do that. Let's create a for loop. So if I created a for loop for item in sequence, print item. So you can probably guess what's going to happen. It's going to say, hey, I'm gonna index through every single element in sequence. Essentially, you're saying for every item inside of sequence, print the item. Okay, so it's gonna basically say, okay, first I'm gonna print 0. This is gonna be 0. Okay, print 1. Okay, loop it again. All right, now we're on number 1. Print item number 1. Okay, so it's gonna print 2. It's going to loop again, print item number 2, and it's going to loop over and over and over again until it gets to the end, and it prints all of them. So if I were to run this, that's exactly what happens. So 1, 2, 3, 4, 5, 6, 7. So you can technically do that with not just like lists, you can do this with dictionaries. So if I were to do like, I don't know, Sam, Frank, I don't know, we could probably give it names from people in here. You can give it Alberto. Berto.
Weapon?
Nothing, you can be quiet again. I'm
Alright.
creating a dictionary and I'm using you as an example. Let's see, I'll do Emmy, I'll do Eric. I don't know who all is in everybody in here, so whatever. Let's see, and then Kenta. Okay, so I can loop through this as well. So if I were to do, if I just wanted to print the values in this, I can leave it the way it is now. So if I were to run this, okay, something came up. What did I do wrong? Oh, yeah, sorry. That's not how you do a dictionary. A dictionary uses semicolons. So now if I were to run this again, is it not going to work again? What did I do wrong? Oh. Okay, try it again. There we go. Okay. So, this actually just printed out the keys. So if I just wanted to print out the keys, this is how I would do it. Okay? If I wanted to print out the values, I would do, instead, I would do, I would do sequence, item. I would do this. And now it'll print out the values. So there we go. You can use a for loop to do one or the other. Okay, so all right, so that's for loops. Here's a while loop. I equals 1 while I is less than 5. Print. So we can use the concept we used earlier about inserting like the whole like I is this dot format. And we can do I, and you can say I equals I plus 1. So what will happen here is first I said I equals 1, and it's essentially going to count up until it gets to number 5 while I is less than 5, right? That's what the loop is going to do. It's going to count up to 5, print the value of I. I is, what number is it currently? Okay, and then now add 1 to I so that we can go up 1, and it doesn't loop forever. So I'm going to run this. I is 1, 2, 3, 4. Didn't print 5 because we just wanted to say before it gets to 5. So what if I just said while true? It's gonna loop forever, and I might break my computer, but let's see what happens. Yeah, I don't want. Okay, can stop now. Python, Python, hello, Python. Okay, new terminal. All right, there we go. That was gonna be a problem. All right, so we don't want that to happen ever. So if your loop loops forever, and your computer breaks, it's because you didn't set a limit to your loop, essentially. So I want to make sure it's only going to be, well, I is less than 5 or 10 or something. I'm going to run it again. There we go. It's not going to go forever. Okay, so we're almost done. We're only going to go until 7. And I think we've almost covered most of the basics for Python syntax. I'm going to try to end it off on object-oriented programming. I'm almost there. Let's see here. Let's do range. So range is kind of cool. A range is essentially a range of numbers. So if I wanted to print a range of numbers, I could do print. I'm going to create a list. So first I'm going to say, I'm going to make a list, okay? Parentheses, range. And I said, oh, I want you to make a list in the range of 0 to 3. Okay? So it should give me a list from 0 to 3. So 0, 1, 2. So it's going to be before 3. So if I wanted the 3 included, I would say 0 to 4. There we go. So let's say I wanted to just make a list of even numbers. I can make a step size. So I can say make a list from 0 to 11, but only include every other number. Okay? So I say every other number by saying 2. So it's going to be every 2 numbers. Okay? So I'm going to run this. So 0, 2, 4, 6, 8, 10. So that's how you do that. So the first 2 numbers are the range. The last one is the step size. So I can actually do a step size of 3. That would be every 3rd number. Okay? So odd numbers, essentially. You can do 4 and on. You get the idea. That's how that works. Another really cool way you can use range is you can use it in a for loop. So you can say for item in range 10. So basically I'm saying like in a range of 10 numbers, print all of those numbers. Okay? It's a really good way to basically do a quick and dirty countdown or something. So there you go. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's how you do that. And yeah, that is how you do that. So now let's do functions. So if you're not familiar with a function is just like a block of data you predefine and you can call it again later. Okay, so if I said define my function and I said parameter 1 equals default, okay, if I did that and I wanted to say within, oops, you need a colon here to make it official. If I wanted to say that inside of this code block, all it's going to do is it's going to print the string out. My first Python function. Okay. So let's say later on, okay, cool. I'm going to save this for later. This is a really important function in my program, and I want to use it later on. So I say my function. Okay, that's all I need to do. If I were to run this, it's going to print that string. Okay. So you get the idea. What if though the parameters required? Let's see here. Let's say I did not include this. I said parameter 1 and I said my first I like the color this dot format, and I said parameter 1. Okay, so now I can't run this unless I have a parameter, right? I'm gonna get an error because this parameter is now required. It's not predefined. So now I have to say something like my favorite color is blue. If I run this, now it will run. So this is how you can kind of like start seeing how you can use this to your benefit and make it more kind of dynamic by using it later. I can make a second I can basically copy this and run it again, but this time change it to red. So now it's going to run it twice, but one's going to say blue and one's going to say red. Okay, there we go. So that's a function. In Python, you don't need to have a return value in functions. So if you've ever done C++, you will know that you need to have like a return value if it's not a void function. You can do that in Python as well. So I can do something like, I don't know, define, delete this, define my function, and I can say return hello. Okay. The difference is that I can't just say this. Okay, I can't just do that, because if you notice here, I'm returning a string called hello. Okay, you can't just put in a string hello here and expect that to run. It's not going to run. Like, what do you want? Python doesn't know what to do with just a string. Nothing's going to happen. What you have to do is you have to print it, kind of like you do with a string. So print. There you go. So print my function. There we go. Hello. So you can also do that. Okay. Anybody have any questions on functions or anything?
The question, sorry. For a for loop, it's kind of weird for me because if you do for item in, I don't know, you give it a list, like you showed earlier,
Yeah.
it showed when you put print item, it showed the item in the list, but when you put print item and then brackets,
In my list,
I forgot.
print.
Is is it is item does item change from like zero from the value to zero, or I'm confused how that works?
So
Explain.
basically, what's gonna happen here is
Yeah,
every.
right there. So print item, you'll print 1, 2, 3, 4, 5, 6,
Mhm.
right?
Yeah.
But when it's a dictionary, you use item as an index.
Yeah. Yes. Okay. So I see what you're saying. Okay. So you're asking why? Like, why it does that?
Yeah. So is item zero? I mean, the index, or is item the actual value? I'm confused.
Yeah. Okay. So yes, you can see this as kind of like the index, right? So this is technically functioning as the index. It's not exactly the index. All you need to know is that you created a variable called item, and you're kind of doing this. You're kind of saying kind of if you remember in a while loop, so you do I equals 0, right? While I is less than 3, uh, print 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 my list I. Okay. And then I equals, you can actually do I plus plus. Actually, plus plus, that might not even work in Python. I don't know. Probably not. Okay, so I equals I plus 1. Okay. This will do the exact same thing as the for loop, except this kind of tells you what's happening up here. Okay. So basically, what's happening is I'm saying I'm creating an index I, right? I equals 0. Okay. So this loop will say while I is less than 3, because there's 3 elements here, 0, 1, 2, 1, 2, 3. Okay. We're going to print my list I. Okay. To start off with, I equals 0. So it's going to print the first element, 1. Okay. It's going to go down here. It's going to increase to 1. Okay. So now it's going to print 1, and then 2. And that's going to end. Okay. So if I were to run this, I'm going to delete this first. Delete this so that you can see this working on its own. I'm going to run it. Oop, what happened? Object is not subscriptable. Let me change this to something different. My list. Let's try this. Let's try this one. Professor Alberto. Okay, well that's not working. I don't think we can index this. But okay, so going back to what you were asking, I was trying to show you like how that works exactly. So the item is, yes, it's basically kind of like the index. It's essentially saying like, okay, um, let's say item is equal to 0 first. Index 0, okay? Print item. Item 0 is 1, okay? Now item is equal to 1. Print item 1. That's 2, okay? Now print 2. And then now item is equal to 3. So it's basically incrementing the value of the index in the background. You can't see it, but that's what it's doing. You're just kind of giving it a value. You can even call this whatever you want. I can say for number in my list. I can change this to number. It doesn't matter what this is called. You can call it whatever you want. It's going to be the same thing. You're just kind of like it's in the background increasing the index, and it's outputting the value of that index, but you gave it a variable name so that you don't have to see it. I was trying to show you with the list, and I don't think a list is indexable, which is kind of embarrassing because I showed you earlier how that works. But
Okay.
you get the idea.
And I have another question. Can you use if else else else, or do you have to use if and then else?
Yeah, you have to
So
do, yeah, you
if
have to use elif. You can't just, so you have, if you wanted to do like x, if you want to do if 3 is 3, right? Print hello. And then you wanted to give an alternative answer in case this is false. You have to do elif, and then you have to give another condition if 3 is less than 2, or print hi, okay? And then you could add another one. You could do elif 2 is less than 3, print by, and then else. You could only have one else. And the
okay,
else does not have a condition. Only the elif and the if. Those require a condition, but the last one does not. The last one is basically if all else fails, this happens. But you can't have multiple else's. Print I don't know. I don't care. Hello. You can't have another else. I mean, you can. You probably it'll probably let you. And it doesn't. It looks like it does. It won't let you. But it will basically, like, if let's pretend it did let you. It's only going to run this one. It's only going to run the first one. It doesn't care what the next one says. But the next one's false because it's like, where's my if statement? Because this already ended. This whole block already ended. So this one's looking for its own if statement. So you would have to make a new one. X is greater than 3. Print blah blah blah. Yeah.
okay, thank you. And as far as functions, I'm okay so far.
Okay, cool. Right on. All right, so you can also have multiple conditions. You can do like let's say number 1 equals 1, number 2 equals 2. And then I wanted to say, let's say define add number. So I wanted to say num1, num2. Actually, I'm going to delete this because I don't need this. Decided I don't need it. Define add number. So we're creating a function, and then we're going to add an if statement inside of the function. So we're going to make this a little more interesting. We're going to say type num1 is equal to the type of num2 is equal to the type of 10. Okay? So I'm actually going to change this a little bit before I finish this, but let's see. Return num1 plus num2. I'm going to tell you exactly why I'm doing this, because this is actually super important to learn. Let me take integers. Alright, so you can probably guess what's happening here. There might be a time you might need a function that it only takes one data type, okay? So let's say I said print add number, add a num, my new function I just created, and I said 1 and 2, okay? Ideally what's going to happen, it's going to add, so my function is essentially what it's doing is it's adding these two numbers together. So 1 plus 2, you can see right here, return num1 plus num2. That's what it's doing. All it's doing is it's adding. It's a calculator, right? With just two numbers. If I'm going to run this, it should be 3. So 3. But if I'm a programmer, I want to make sure that my user isn't breaking this program by accident. Let's say somebody, because you have to assume your users are kind of dumb, right? Yeah, that's kind of how you have to do things when you're a programmer. You have to think of the worst case scenario and you have to program around it just in case somebody tries to get to the worst case scenario. So if I did 1 and then the string 2, that shouldn't work. That technically should not run because this is not an integer. That's a string. So if I were to run this, it should tell me, sorry, I only take integers. I'm running this. It actually gave me none. Actually, that's not what it should tell me. Run none. That's not what it should. What is the problem? Return else. Oh, let me try this. Let's try return. Return that. There we go. Okay. I forgot the return. So there we go. So the way this works is I added these things called type. So I added an if statement saying if the type of number 1 is equal to the type of number 2, so we can assume that they're both going to be integer variables. So by definition, I'm already saying that it should equal to the type of 10. So you can see at the end that there's a number 10. All this is serving is it's saying, hey, Python, I want these two numbers to be the same type as 10. 10 is an integer. So make sure that when the user runs this, it's the same type as 10. This whole thing has to be the same type as 10, which is an integer. If it is not, if this whole thing is false, if it is not the same type as 10, then do the else statement. Return, sorry, I only take integers. So that's how this works. So that's how you would do that if you, to prevent users from like using a different type. And now this should work for, so there you go. All right, cool. Let's move on to scope. I don't know, should I do scope? Scope is kind of, I don't know, I might go back to scope because we're almost done. We only have 17 minutes. So object-oriented programming. Let's go to our object-oriented programming. This is arguably one of the most important concepts in Python and programming because it lets you reuse code. So we are going to go ahead and start by, let's start by doing something like, I'll show you an example. So what is an object? So when we think of, when I think of an object-oriented programming, you must be wondering, like, what is an object? So if I created a list, my list equals 1, 1, 2, 3, right? If I said my list dot append 4, what am I doing exactly, right? What is happening? Technically, we are adding an object to this list. We are adding an object to this list of this. There's a list of objects and they're all integers. Integer is an object, okay? So we're adding 4, that's an object. So if I'm gonna run this, print my list, we go from 3 objects in this list and now we have 4 objects, okay? An object, in Python, everything is an object. This is gonna be a confusing subject if you don't have, if you've never talked about object-oriented programming before. Just know that an object is essentially like a data type. We talked a lot about integers and we talked about booleans, so let's talk about data types, right? Data types. There is integers. There's integers. So x equals 3, y equals 4. Okay, those are integers. These are data types called integers. Okay, and then we have booleans. We have different objects called a equals true, b equals false. Okay, these are 2 different data types. Okay, these are their own data type, their own kind of object. So this list is an object, but it's also an object that contains other objects. That's confusing. So the easier The more I explain it, hopefully the more it makes sense. Okay. So let's do something called, I already kind of explained this to you. So if I did print type, so you can find out what kind of object a variable is by using the type kind of uh, class. Okay, this is a class technically. So we can use this to find out what type of object it is. So if I did type x, it's going to tell me. It's an integer. So at the bottom it tells me, oh, what kind of class is it? So by the way, an object is a class. So in object-oriented programming, a class is an object. Okay? It's just that there's a small difference that yes, objects are classes, but objects are essentially classes in action. A class, imagine it's like a blueprint. So if you got into programming knowing you're going to create these big programs that when you run them, they're going to follow all these instructions sequentially and give you like an end result, right? That's a whole program. Essentially, that's what a class is. A class is a whole set of instructions that you predefine, kind of like a function like we did earlier when I defined a function and I said, okay, run these instructions. When I call you, run those exact instructions. That's a class, except it's bigger. It's bigger, and when you call a class, you don't call it a class. When you call a class, you call it an object, okay? So in this case, x is an object of the class int, essentially. There's a class somewhere called int that defines the data type integer, but when you call it in Python, when you use it, it's called an object. So I hope that makes sense. So if I were to do another one, so let's say print type 2.0 should be a float. There we go. That's a float. If I do this again, print type, let's say I did, let's do a list. Let's do my list. My list equals 1, 2, 3. I did my list. Now we're to run that. Actually, I don't know if this will work. It probably won't work. Yeah, it doesn't work. You have to give like an individual element. So let's do that. Is that not gonna work? That might not work. Actually, let's do this. 2, 3. Yeah, that'll work. Oh, should be in lists. I guess that won't work. Never mind. Oh, I see what's happening. Oops. Try that again. List. There we go. That's a type list. So if you don't know what kind of data collection, data structure you're using type is a good way to find out what kind of object it is, right? So there you go. That's how you can do that. So classes. Let's create a class, an example class. I already talked about what a class is. So to create a class, you start it like this, class sample. Pass. Okay. So this is our first class. The way a class is created, you start off with the keyword class, capital letter. It has to be capital. I mean, it might let you do a lowercase, but that's not the convention you want to use for a class. They always start with the capital letter because it tells the people that read your code that, oh, capital letter, that means it's a class. So that's important. Okay. So this pass just means don't run anything. So if I were to run this, nothing happens. Okay. So if I were to create a, pass. If I were to create a variable x equals sample, okay? Like if I were to create we just created an object. X is now an object of the class sample. So if I were to do print type x, it should tell me that it's a sample. Data type, it's sample. It's a sample object. Okay? So there you go. Okay? Except that the difference is that when you create something on your own, it's going to have like this underscore, underscore, main, underscore, underscore. But that's okay. All right? So you can create attributes. So attributes are basically just kind of like variables, okay? They're characteristics of an object. So let's change this class to be called, let's say, dog, and let's give it an attribute. Let's say that it's a species. The species is mammal, okay? A dog is of species animal. All right, that's an attribute. We just created an attribute. Okay, so if I wanted to call this somewhere else, created a, let's say I wanted to, oh, I don't know. Let's see, print dog dot species. Run this, gives me mammal. Okay, so that's how you would kind of like print something out within a class. We can add another attribute like, oh, eyes 2 has 2 eyes. Bark equals true, right? I can go on and go on and on, right? There's something else that we can do. So I'm trying to find a good way to describe this because, okay, let me just kind of do it and then I'll kind of explain what it is. Init self breed eyes bark. Okay. Then we'll do something like, actually, no, we won't have anything here. Bark. We'll do self dot breed, self dot eyes, self dot bark. Okay, equals breed equals eyes equals bark. Actually, I'll delete this name. None. Okay. Actually, I'll delete this. Sorry. C name equals name. Okay. So this is how this is going to work. Basically, what we just did. I gotta make sure this is going to work. Otherwise, sorry. 1 sec. So, oh, it's because I don't have. There we go. Okay. All right. So the way this is going to work, we basically just made required attributes. These attributes are required. A dog needs to have a breed. It needs to have a name. So let's say we want to do that. So let's say we create a dog. Okay. We're going to create an object. We're going to say my dog equals dog. And we're going to say the breed equals lab. Okay. And we're going to give it a name. We're going to call it, I don't know. I've always thought the name Cubo is a cool name for a dog. Cubo. And then we're going to print this out. Okay. So now we're going to print my dog dot breed. So now it should print out my dog breed. So it's a lab. If I were to print out the name of my dog dot name, okay, should print out the name of my dog. So now it's Cubo. Okay, so that's how you create an object. I could create a new object. I could create a, I don't know, Emmy's dog. Okay, make a new dog and give it a different breed. I don't know what kind of dogs Emmy likes. Let's see. Let's do a Chihuahua. We'll call it, I don't know. Little. I don't know. So then now we're going to print this. We're going to print Emmy's dog. Oh crap, that scared me. Who unmuted themselves?
It was me. You called the dog. Tiny.
Tiny. Okay, alright, we'll call it Tiny. Alright, so oops, and actually that's good because we need to do this. Name equals little. Tiny. Call it Tiny. So now if we were to print this and call it, let's say, oh, print Emmy's dog dot breed. That'll print that out. And then Emmy's dog print Emmy's dog dot name. That'll print out her dog. So there we go. That's how a class works. Okay, so a class is essentially like a giant piece of code. You give it attributes, and you can require some attributes that you need to define so that whenever you make a new object out of it, it needs to be unique, right? That's how that works. So yeah, that's classes. And let me see if there's anything else I need to go over here. I mean, there's a whole lot more, but we'll go like way past 7 if we do. So I'm not gonna go any past 7. Because there's more that I could have gone over. I could have talked about inheritance and methods and everything, but I don't know. I might run another workshop some other day to like talk about that stuff. But yeah, does anybody have any questions that I can
I have
answer?
a quick question.
Yeah.
Could you show me how, like, if I wanted to do user input, how would I do that?
Yeah, user input. Actually, don't know in Python how to do user input. Let's find out. We can actually Google this together because I have no idea. Let's see, user input in Python. Because whenever I use Python, I use it for Django, and generally I don't use a console. To get user input, I use Django, which is different. So I guess to do that, let me move it over here so I can like. Let's see, input. Okay, so the way you do it. So I'm gonna delete all this. So we can create a username. Username equals input. Enter username. Okay, and we can get a little creative. Okay, we can say print username is, and we can say we can do it one of two ways. We can say username is, concatenate it, and say username. Okay, so then when I run this, it'll ask me down here, and I say, oh, Eric, username is Eric. Okay, or we can do kind of like what we did earlier, format. Okay, and then we can do username, do this. Okay, run that, and do Eric, and it'll be the same thing. So that's how you would do that, user input.
Yeah. Thank you.
Yeah. All right, guys. So I think that'll be it for the Python
Wait.
workshop. So
Eric,
yeah.
real
what's
quick,
up?
I have a quick question. It should be quick. I just have a quick question regarding initializing the object.
Yeah, no worries.
I see that you use question equal sign. Can you just use like instead of using equal sign, can you just like put the actual value in there? So like you would put a string quotes. If you go back to the you know you lost it. So can you initialize a quick object real quick, like tent? We're doing the same. We're using the same object as before. Dog.
So like class this, like that.
Yeah. Okay. And then yeah. And then when you initialize it, you put uh dog equals. Can you just put the dog? I mean, can you just put the string instead, or do you have to put equals?
Let me see. Let's see how far back it goes. There we go. Okay.
Right there. Yeah. You see,
yeah.
instead of using breed equals lab, can you just put lab?
No, because
Okay.
I mean, let's see. We can try it. See what happens. If I were to run this, it's not gonna work because the name isn't defined. We can do it if we did this. If we did like name. If we did breed equals lab. So if by default your class already has these defined, you can do that. Name equals, I don't know, Alex, and I think this will work. Let's see, probably it did not work. Let's see if I did this. I know there's a way to do this. It's just it's been a while, and I have to play around with it a little bit to kind of remember. There is a way though. Actually, I think you can probably, if you deleted this, I think it might work. So if I did this, I would have to delete this too. Delete this. Let's run this. So that'll work. Okay. If you don't put the initialization kind of function that I
Okay.
had, because that'll kind of require you to kind of define that when you create the function. When you create the object, it'll require you to kind of define them, but now you don't. So that's one way to do it if you wanted to try that. Yeah. So
Thank you so much.
yeah, dude, you got it for sure. So now that you kind of know some of the basics from Python, um, when I learned Python, like over a year ago, I did all the basics from here. I learned a little bit more. I learned a little bit more about objects and everything, and that kind of taught me enough. But now you can do stuff like Django. You can do stuff like Django. So now you can probably learn about doing like making like apps, like I don't know, like a Facebook clone. You can make like an Instagram clone. So you can do Django. Django is written in Python. That's one thing you can do. You can also learn. So I'm just kind of giving you some suggestions if you wanted to kind of like take Python to the next level, and you wanted to make some cool projects. Django, you can use it to make like database apps like Facebook, Instagram. You can now learn TensorFlow. That's if you wanted to create stuff with like machine learning. So that's pretty cool. Flask. Flask is similar to Django, kind of the same thing, honestly. Um, yeah, those are kind of like the most famous things that I can think of that you can probably use Django with. I mean Python with. So yeah. So
I,
yeah, sorry, go ahead.
sorry. I have a question. Is this being recorded or no? Is it just like
What's
on
that?
the side? Is it being recorded
Yeah, it's recording.
or
Yeah,
okay?
yeah. Let me double check it, make sure that it's not like, yeah, it's recording. Yeah. So I'll upload this to YouTube. So if you want to
Yeah.
kind of go back and like look over it, you can do that. All
Yeah.
right. So I'm gonna stop the recording.